Hello, I'm a designer who loves working in AR VR design space. I'm a newbie in both C# coding and Unity who struggle most of the time when prototyping. But when it works, the joy surpasses pain and wanted to share the joy of making, especially with non-programmer like myself. Hence this simple tutorial video. Okay, that was a little bit of me, and let's get started. In this tutorial, I will show how to create a simple projectile in HoloLens like this. Not covered in this tutorial, but you can create more exciting looking things like this based on this tutorial plus additional script as well. In this tutorial, first we'll instantiate a projectile when user makes an air tap gesture. Then we'll add spatial mapping so the projectile will react to your environment. Before we start, please download HoloToolkit Unity at GitHub and follow the instruction on the Getting Started page to create HoloToolkit Unity package. I also included links to those pages below this video. Create a new 3D project in Unity and import HoloToolkit package by selecting Asset, Import Package, Custom Package, and then select the Unity package in the file picker. Since we don't need examples for this projectile, we'll uncheck HoloToolkit Examples, then select Import button. It will take a while to import all the assets, so hang tight and take a sip of coffee. Before we dive into building projectile, we'll optimize Unity settings for HoloLens development. Select the Edit button in the top of the screen, go down to Project Setting, and then select Quality. Over in the Inspector panel, you will see a series of checkboxes. Find the Windows Store column and click on the downward pointing arrow and then change it from Fantastic to Festus. We're doing this because maintaining high frame rate on HoloLens is so important when the quality setting to be tuned for Festus performance. Next, go to File and click on Build Settings. Under the platform, select Windows Store. To the right, select the SDK drop-down and then change it into Universal 10. Make UWP build type to D3D and select Unity C# projects. Before we close this dialog, select Player Settings. In the Inspector panel, under Windows Store icon and under Other Settings, select Virtual Reality Supported. If you don't check this, which I sometimes forget to do, your app will be rendered as a flat app, and we surely don't want that to happen. Okay, we're done with the project setting, and before we really start, we'll save the scene first. We'll create a folder under Asset by doing right-click, Create, Folder. We'll name it Scene. Ctrl S to save the scene. And select the scene folder. We'll name it Simple Projectile. Now, delete the default main camera in the project and bring HoloLens camera prefab that is under HoloToolkit, Input, Prefab folder by dragging it to the hierarchy. This camera is optimized for holographic development. Also, drag and drop Input Manager prefab that supports various input sources supported by HoloLens, including gesture and speech. Now, it's finally time to create a projectile prefab that we will instantiate when we make an air tap gesture. Prefab is like a cookie cutter, a mold for game objects that enables you to generate a cookie that has the same shape, attributes, and properties you define over and over again. In order to create a prefab, we'll first create a sphere inside the hierarchy by doing a right-click inside the hierarchy panel and select 3D object and then sphere. In the inspector panel, I'll make it smaller by putting 0.1 in scale instead of 1. In case you don't know, 1 equals to 1 meter in Unity. So by putting 0.1 in scale, the diameter of the sphere becomes 10 centimeter. Then, we'll add rigid body by clicking Add Component button and then type rigid body, select and hit Enter. In case you're not familiar with it, rigid body is required for any physics-based interaction. It allows the object to fall under gravity or to be affected by forces applied to it. Without rigid body, our projectile will simply stay in the same place. but when we add rigid body and enable gravity and force, it will be thrown away and eventually fall. I hope this was enough explanation of why we need rigid body. As you can see, rigid body has numerous options. Mass is like a kilogram and it affects how collision will be treated with other objects. For example, higher mass objects push lower mass object more when colliding. Think of a big truck hitting a small car. We'll make sphere slightly lighter by putting 0.5 instead of 1. Drag is like an air resistance and affects how quickly it will slow down without other interactions. The higher the drag, the more object slows down. So let's say 10 will be like a feather and 0.01 is like a block of metal. We'll change the value from 0 to 1. Similarly, angular drag affects how quickly the game object will slow its angular velocity. For example, how fast it's rotating. The higher the drag, the more the rotation slows down. We'll leave the value as it is. We'll also leave the Use Gravity checkbox as it is, but if you don't want gravity to make the projectile move straight forward, you can uncheck this option. Now, we'll make projectile makes a sound when it gets instantiated. For that, we'll import one audio file. Again, create a folder under Assets folder by doing right-click, Create, Folder, and we'll name it Audio. Double-click the audio folder and import an asset by doing right-click, Import New Asset, and then click the sound file. Below this video, you can find a link to the sound asset if you would like to use the same sound file. Go ahead and drag your sound source to the sphere. Click the sphere in the hierarchy, and now you can see audio source has been created that represent the audio clip we just added. We don't need to use spatial sound for this particular example because the sound will happen near the headset. But since we're likely to use it for other projects, I will show you how to make sound spatialized. As you can see, there is no spatialize checkbox in audio source because Unity does not load a spatializer plugin by default. To enable it, select Edit in the top menu, Project Setting, Audio, and in the Spatializer plugin drop-down menu, select MS HRTF Spatializer. Back to the audio source component, and ta-da! There's a Spatializer checkbox. Check the box, and drag the Spatial Blend slider all the way to 3D. Now, it's time to save the sphere object as the prefab. First, create a folder under Assets by doing right-click, Create, Folder, and we'll name it Prefabs. Click the Prefab folder and we'll simply drag sphere object to this folder. That's it. That's how you create a prefab. Once you create one, you no longer need this instance in the scene, so let's delete it. Now, we'll create an empty game object that will instantiate the projectile. Right-click on mouse inside the hierarchy panel and select Create Empty, and change the name to Projectile. Then, we'll add script to the object. Create a scripts folder under Assets. Right-click inside the scripts folder and create C# script. We'll name the script Projectile Launcher. Reselect projectile object and in the inspector panel, click Add Component to find Projectile Launcher. And double-click the file to load it up in Visual Studio. First of all, since we're going to use gesture input, we need to add HoloToolkit Unity input module namespace at the top using holotoolkit.unity.input-module. Then we need to add input click handler interface next to monoBehavior class because we are going to use AirTap gesture to instantiate the prefab. In order to find more about other input type interface names such as speech or ready gesture, please check out input section in HoloToolkit Unity page on GitHub. Back to the Visual Studio, now let's create a variable to hold the projectile game object inside the class. We're going to make it public so that we can access to it inside Unity Inspector. Then define the type of variable, which is GameObject in this case. Then we'll simply call this prefab. Let's go ahead and delete update function because we don't need this, and create a new method called it onInputClicked. Public void onInputClicked, and for the parameter type, input event data, and for the name, event data, and open and close curly brackets. You can find the correct method name and parameter type by opening the corresponding script file. For example, here I am using input click handler interface to implement AirTab event, and you can find the script inside Holo Toolkit, Input, Scripts, Input Events folder. Double-click Input Click Handler to open it in Visual Studio, and there is a method name and parameter type you need to copy to your code. Back to our code. Now it's time to write the things we want to make it happen when user makes an AirTab. First of all, we need to make the projectile sphere appear. Let's make another GameObject variable called a projectile to hold a clone of the prefab. To do that, we'll use instantiate function and put the object we want to copy inside the parenthesis, which is prefab object in this case. GameObject projectile equals to instantiate prefab inside parenthesis as GameObject. Then we'll set the initial position of the projectile to be slightly ahead of the user by using transform class. Projectile dot transform dot position equals to camera dot main dot transform dot position, which is user's current position, plus camera dot main dot transform dot forward, which is the direction user is looking at, multiplied by 0.85. Then, in order to add force to the projectile, we need to access to its rigid body first and then add velocity to it. First, we'll make a rigid body variable using getComponent. Variable type rigid body, we'll call it RB, equals to projectile.getComponent and type rigid body inside angle brackets. Now, we'll add velocity to the rigid body. RB.velocity equals to camera.main.transform.forward multiplied by 10. There's one last thing you need to add. By default, Holo Toolkit input events are sent to the currently focused GameObject, which means GameObject needs to be present to trigger AirTab event. But in our case, there's no focus GameObject. Instead, we want to instantiate a GameObject when AirTab gesture is detected. For this particular case, Holo Toolkit provides models input handlers so that the application can react to global inputs that aren't targeting a specific element. Holo Toolkit provides 3 models input handler, which you can find it in Input Manager script. We'll use push model input handler to push this empty GameObject into the model input stack. We'll add this inside star method so that it will be called first. Input manager.instance.push model input handler and this GameObject inside parentheses. Now, save all and go back to Unity. Once Unity compiles a new code, you will see new prefab section in the inspector panel. Drag the sphere prefab we created before to this area. Now, it's finally time to see this in action. Hit play. You can simulate AirTab by either holding space for the right hand or shift for left hand while clicking left mouse button. Ta-da! There's your projectile. Now, get out from the game view and save the project. You don't have to deploy this to the device yet, but just to show you how it looks like in the real world, I will do it by selecting Holo Toolkit on top and select Build Window, and then Build Solution Apex, then Install button. This is how it looks when deployed. As you can see, it has no understanding of the real world, which we'll fix in the next step. Now, it's time to add spatial mapping. One of the biggest strengths of Windows Holographic is its ability to understand and interact with users' world. This allows interesting dialogue between your hologram and the real world, and more amazing thing is that it's super simple to add. Just 2 steps. First, we need to add spatial perception by selecting Holo Toolkit on top and configure, then apply HoloLens capability setting and check spatial perception inside the dialog box. Then, we need to add spatial mapping prefab, which is under Holo Toolkit, Spatial Mapping, Prefab folder. Drag spatial mapping prefab to the hierarchy. That's it. That was really simple, right? If you look at the inspector panel, there are a couple options where you can change surface materials and turn on and off the visual meshes. I will just leave them as they are and save the project. You don't have to deploy this, but again, just to show you the difference, I will do it. This is how it looks when deployed to the device. As you can see, now our app understands the environment, so projectiles stay above the grass rather than infinitely fall to the center of the earth. There's one potential problem though, which is performance issues due to too many projectiles. So next, I will show you how to set the lifespan of the projectile so that it will not stay forever. Now, we will add a script to the projectile that makes it disappear after a certain duration of the time. First of all, we'll create a new script. Select Scripts folder and right-click, Create, C# script. We'll name this Destroy Projectile. Then, we'll add this script to our projectile prefab. Select the prefabs folder and select Sphere object. In the inspector panel, select Add Component button and search and add Destroy Projectile script. Double-click the script to load it up in Visual Studio. First, we'll add a float variable to hold the value of the time when projectile is emitted. Private float, and we'll name it projectile underscore emitted underscore time. Then we'll create another float variable to hold the value for lifespan. We'll make it public so that you can easily change the value through Unity Inspector panel. Public float, and we'll name it projectile underscore duration equals to 7.0 f, which means float, and this equals to 7 seconds. Next, we'll get the value of the projectile emitted time. Inside start method, projectile underscore emitted underscore time equals to time dot fixed time. For those who are not familiar with it, fixed time is a time in seconds since the start of the game. Then we'll create an if statement that commands to destroy projectile if it has existed longer than the set lifespan. Inside update method, if time dot fixed time minus projectile emitted time is bigger than projectile duration, inside the curly bracket, destroy this game object. Now, save the code and go back to Unity. I will deploy it to the device once again for the last time. Holo Toolkit, Build window, and select Build Solution Apex, then Install button. One, 2, 3, 4, 5, 6, 7. Now, as you can see, projectile disappears after 7 seconds. I hope this tutorial is useful for someone, and thanks for watching.